Welcome. In my free time, I build a lot of software side projects, primarily for education and fun, but also sometimes I need something useful for myself. This time I've decided to build a personal budgeting application from scratch, and I want to record the entire process as a YouTube series because I think it would be fun to make this series of videos, and also someone might find something useful in the entire series which I make. So let's first address why would I build a personal budgeting app when there are hundreds of them, literally. I've tried many of the most popular ones over the years, and there are a lot of very future feature rich applications out there which become very complicated because they attempt to support every possible budgeting style, or they attempt to be so flexible to allow you to make complicated and very adjustable budgets. But as a result of that, you get a very complicated app, which you need to spend a lot of time learning and analyzing in order to just understand simple reporting and where your finances are at. And I think most people, when they are looking for a personal finance app, especially, they want something simple to streamline their entire financial life personally. So these complicated apps are really a no-go for me. Although I can understand most of them, I've used many of them, and if I spend the time, I get how they work. It just that clutter annoys me on a day-to-day basis. On top of that, supporting so many features means that these apps are usually subscription-based or a paid product, which is understandable. They are very future-rich. But I wouldn't want to invest money in something like personal finance tracking, or at least personally. And in addition to that, many of them have annoying features like integration with your bank account to record transactions automatically. Some of them don't work without that. They don't work with manual transaction tracking, which sounds cool in theory to have your transactions automatically recorded. But in practice, I found that very unreliable. Also, you don't want all of your transactions tracked, so I found myself, instead of recording my transactions, inspecting them and removing some, which is even more bothersome, and it feels like more of a chore than recording my transactions. So this is one category of apps, very complicated apps that are not pleasant to work with. There's also good applications, which I've found many of them, in fact. Unfortunately, the great apps I have found are usually region specific, and they don't allow users from the entire world. More specifically, most of them are US only, which I cannot use them, and many other people can't. I'm sure they have their own reasons. Maybe they have very good reasons to not allow users outside of the US, but the reality is they don't. So they're no go. The other route you can take, which is a very simple route, is to not use an app at all. Just build a spreadsheet. In fact, spreadsheets are great at things like personal finance. You can organize your budgets in, you can make the spreadsheet as complicated as you want or as simple as you want. You can use any budgeting method. Yeah, you need to research it, but it's not that hard. You can do that. The biggest problem and advantage of spreadsheets is the same thing, actually. They are very flexible and easy to modify and iterate over, which means if you do a monthly based budget, for example, you might have 12 budgets in a year. I find myself, when I have a spreadsheet, that I modify and update the spreadsheet every month or every 2 months, but very frequently. I'll change the structure, I'll add additional data, change the reporting format, change the entire layout. If you need to look up historical data, which is one big factor, if you record your finances, you do it to also be able to reference past budgets. You might find a budget 6 or 12 months ago unrecognizable in terms of layout, structure, reporting. Because when you do small changes all the time, over time, the entire spreadsheet becomes much better, but also very different. So that's a very big downside of spreadsheets, I think, which doesn't happen with apps. Although they are harder to implement a new feature on, if you implement a new reporting feature, a new feature in terms of data recording, it gets implemented for historical data as well. And of course, you can go back and update all of your spreadsheets with a new feature, but literally no one does that, and you shouldn't really. Why would you? You might have months and months and tens of spreadsheets, and there's no point. So these are my reasons. Valid or not, I'm building the app. So I've decided to record this series. I expect this to be a 5 to 10 videos long series. I'll try to include as much of the process as possible. Of course, I won't include some very bothersome, I think, parts of the process, which I don't think will be interesting to anyone, something very repetitive. But I'll definitely include all of the development. I will try to include as much of the entire process as possible without making the videos overly long and boring. In this first video, I will not write any code. I like to, when I make a side software project by myself or with other people, I like to first think about architecture. I like to make, to specify clearly my functional requirements, to make an entity relationship diagram for my database, see the entities of the database. If depending on the project, if it's more custom, like an application, I would sometimes create a class diagram even to see how the data would flow, how the objects would interact with each other. I do that to save me time rewriting code. You can absolutely start writing code. There are many ways to develop software. Many of them, of the methodologies, involve just starting to write code. You can absolutely do that and figure out the architecture while you're writing the code. Many people prefer to do that. I find that a little more time consuming and chaotic. If I specify my general architecture as cleanly as possible before I start developing, I usually have to rewrite less code. I rarely have to rewrite the whole application, and it just feels more organized in terms of process. So let's jump into the first things. I'll show you the functional requirements and what my app will do, at least how I specified it. And then we'll talk about the database structure and the entities of my database. All right, so here I have a Markdown document, which is formally some sort of SRS or software requirement specification. Now, this is usually a formal document which describes very specifically how the software will function, what its target users are, how they will use the software, many other things, including functional, non-functional requirements, and all other specifics in relation to user software interaction and the specific requirements for the software. Now, you don't need to do this formal document as it's intended to be in its fullness, because especially if you're building software yourself, you're building an app by yourself, this is a document for you. What I like to write for myself are the functional requirements in a clear list like this. You can even do that in a text file in your IDE, just code or whatever. In this case, I wrote a quick summary of the app. This is just for me. I feel like I get a clearer understanding of my idea if I write it down in textual format and edit the actual text a bit. Sometimes I can get a clearer statement about what the application will do. So I do it for that. But I want to focus on the functional requirements because they really specify what the application should do and what kind of features it should support. So this is what we will be implementing basically. Now, I did write, I'll go through these. They're quite simple. They won't take a lot of time. I want to support income, expenses, savings, and debt transaction types. So, of course, this is a personal budgeting app. It will support transactions. There are different types of transactions, and these are the 4 types that I've recognized as important in terms of the functionalities the application will support. The differences between these are the income is, of course, the money that will be flowing into the budget for the period. Expenses, of course, are the money going out. And savings and debt are special in that savings are basically funds which you fund every budget period with certain amount of money and they accumulate, which is different from income and expenses because they don't have an accumulation value. And debt is basically the opposite. You have a certain amount of a certain amount which you have to pay off, and each month you will plan and pay off a smaller fraction of that. So these are 4 distinct types of transactions, and categories, which I need to support in my app. Of course, users will be the next functional requirement is that users will be able to basically perform CRUD operations on custom categories for each transaction type. So I call these transaction types. So you'll be able to create different incomes, different expenses, savings, and debts. That's pretty normal, I think. The budget will work on a monthly basis. That's one decision I made. Many applications would allow you to specify custom periods and stuff like that. But the fact is, most people budget on a monthly basis. Each category will support the planned versus actual spent amount for the month, so that's pretty basic. I want to have a pie chart of spend money by categories for the month. That's very important and a fundamental of reporting. You need to be able to search in transactions. That's vital. Savings should support accumulated saved amount. I already talked about that because savings are not only on the monthly budget basis, but also you create a fund. You fund that fund with certain amount of money each month. You would ideally want to see how much you've accumulated in that fund at any given time. Debt categories should support leftover to pay amount. This is the opposite of the savings, basically, the negated logic of savings. And a new user should get a default set of categories. So as I mentioned, you'll be able to create custom categories for each of these: income, expenses, savings, and debt. Of course, when you start, you don't want an empty screen. There should be sensible default categories, which most people should be able to start off of. And lastly, when creating a budget for a month, you should be able to copy a previous month. I think that's sensible. You don't want to specify your categories each month from scratch. You would ideally copy the same categories each month or just slightly change them. So these are the most important features which I want to implement first. These are, of course, not comprehensive. This is the bare minimum for my application. In many cases, I would make the mistake of specifying too much features for the MVP, and that usually results in a very long period of time of initial development before I release any app that is useful. And that's not a good practice, I think. Uh, Ideally, in my opinion, the first version of the application should have the most minimal set of features to make to still have a useful app. But this way, you will be able to implement each one of the features in the ideal world. You would be able to implement a robust set of features that are well implemented, tested, and they're working correctly. Then you can always iterate and improve and add more features. But the first version should include only the most important features, and this way you can make sure you develop them properly, test them, and that they're robust. Base of the application, basically. So let's start from here. We have the functional requirements. Next, I would want to specify my entities, basically my database entities in a diagram form, something like an entity relationship diagram. I use this application, Draw.io. Also, I see it's aliased under diagrams.net. It allows you to use your browser to draw diagrams. You can save them to cloud providers or your device as an XML file. It's really nice, free app. So I'll basically create a new blank diagram here and call it entity ER diagram. All right, so this app doesn't have too much of a learning curve. You have shapes here, which are also sometimes lists, and you have some UML diagram presets. If you're doing a lot of class diagrams, that's useful. And you just edit them by double clicking, entering text. Pretty simple and easy to use. So let me remove that notification. Ideally, an entity relationship diagram, if you're not aware, shows the entities or even a relational database, the tables, and how they relate to each other. In this case, I might make an entity diagram. When I specify the foreign keys, basically, I'll see the relationships. I don't think it's that important with such a small set of entities specifying the relationships. I don't want to waste so much time on that. The most important thing is to recognize my entities and how they will work with each other. I don't necessarily need the entire diagram. So I'll just drag a list. You also have the entity relation here section where you have more specific tables for that. Let me remove this. I don't need that. It's not that important specifying the primary key. I prefer a simpler diagram if possible. In fact, let me zoom. So this list, I can drag list items into it and expand it as much as I want. And that's enough for an entity relationship diagram, especially a simple one for this app. So to start, the most important, the most commonsensical table would be users, that entity. That will of course have an ID, and I will identify users by email, which I think is pretty standard. I will specify data types here as the JavaScript data types, which are quite straightforward, string number, etc. Because I plan to use MongoDB in the end, so this will be the closest to the actual data types I'll use in the database. So I will identify my users by email, and of course they'll have a password, which will be a hashed string. Now, besides that, I would want their names. For basic user interface purposes, you would want to be able to identify your user. At the very least, have user interface that says hello to them and stuff like that. These are just the very basic essentials of information from your user. I don't like to collect too much, but I think the name and an email for an identifier is necessary in this case. I don't specify the ID type because, well, in most databases, it's some kind of an integer. In MongoDB, it's just an object ID, I think, or whatever, not necessary. All right, so we have an email, password, first and last name. An additional item I can think of immediately is the currency. So, first of all, currency, a user needs to have a currency setting. If you're doing an international application for personal finance, you need to store the preferred currency of the user somewhere. If you have a lot of settings in your application which are related to the user profile, I am not sure I would store them right here in the user entity. You can create a separate entity for that. In my case, currency will be the only option for now related to the user profile and not saved in the, for example, the local storage of the user or something like that. So I would just keep currency as a user property for now, and we'll see how it evolves in the future. You can always create a separate entity for user settings. So currency will be a string as well, some ISO string, I believe. There was a standard table of currency strings identifying every currency in the world, so I plan to use that. All right. Now, besides this, I think this will be the users for now. As I build this, I add fields which I know I need, and then when I add the other entities, I might add another field to certain entities. At the very least, I'll add the foreign keys for the relationships later because I still don't have other entities. Now, the other fundamental thing in a budgeting app is the transaction entity. Now, transactions will, of course, have an ID and an amount. Transaction is, of course, a certain amount of money moving somewhere. Besides that, a transaction, besides an ID and an amount, should have a certain amount, a certain category. So, as category will be a separate entity because they're user defined. I'll add them right now. So categories have an ID. They have some sort of title. I think that's important. I will convert this to camel case because I think I'll use camel case in MongoDB. It's more appropriate given that will be in a JavaScript environment. Either way, let's go back to categories. A category will have an ID and a title. That's important. Besides that, I think I can remove the third list item for now. Now, categories themselves are basically nothing. They also need to be of a specific type. So let's add this item first. Sorry. So a category should have a type, and this type will be an enumerable property. Let me first specify that title is a string and that amount is a number. So type is an enum, a selection of a few things. I'll specify it like this. As long as it's understandable, that's fine. And I'll add a list of the types right here. That's not an entity in the database, just to be clear, but that's a good way to specify it in this diagram, the different types. And the types will be income, expenses, income expense, savings, and debt. So a category will have a certain type. At least that's how I plan it to work. Because, yeah, basically each type will have custom categories, and the roles in this entity will represent the types, which the user will create or he will have created when he creates his account. Some default categories. Now, besides that, categories are basically not bound to a budget, and a budget is periodical thing. In this application, in the functional requirements, I've specified that the budget will work on a monthly basis. So each category will have a planned amount to spend or whatever, if it's an expense type for the month. And categories right now are not bound by anything. So I need a separate entity that will bind categories to time. And that I'll call a budget. So a budget will be a category for a certain period of time in my design. At least that's how I thought about it when I've designed this in my head, basically, briefly. And the budget will include a category ID, basically, which will relate it to category. It will have an amount. It will have a month, which will be a date. So this budget, as it's a monthly, the app will work on a monthly basis. Each budget will be for 1 month. The amount will be a number. And this is how we will bind categories to basically months, to budgets. So the view where you see all of your categories of planned expenses will be a view of different budgets for a certain month. That's the plan for now. Also, I see right now that transactions should, of course, have a date, which will be of type date. I'll call the field date. That's fine. I don't need date time for a transaction. The time precision of a financial transaction for personal finance is unnecessary, in my opinion. Precision up to a day is good enough. In addition, we need to relate transactions. So far, we relate budget to categories, but each transaction needs to have a category and a budget. And because each budget is related to a category, each transaction just needs to be related to a budget. So I'll add budget ID right here. All right. So this ties them pretty much. Now, in addition, these need to be related to a user because categories, transactions, budgets, these are all user bound. Right now, they're not. Which item goes to the user would be category, which is the lowest level one. This will be related to the user because otherwise we might need to add this field to multiple items. So basically, this is related to a category. This transactions is related to a budget. And if category is bound to a user, which it should be, all of these we can basically identify to which user transactions and budgets are. If the user ID field is in transactions or budgets, category becomes unbound. We don't know which user it belongs to. So the only option at this stage is to add the user ID to categories. And here we get our relationship basically. We have four basic entities. And this enum type is specified like an entity, but it is not. So this is how these relate. in an entity relationship diagram, you would draw the relationships like this. You would usually just relate them like this with certain symbols. I don't think that's necessary to clutter my diagram. I can clearly see the relationships from the foreign keys. I can, in fact, specify this. I would just say PK for primary key and right here. And I'll specify these as foreign keys. All right. Category ID as well. All right, so let me see if I'm missing something. Of course, it's not critical if you're missing something. You can always update this diagram. And this diagram is not meant to be updated forever. It's just a means to an end. You will just use that to build your database or your models or whatever. It's meant to help you with the architecture, not be a burden to maintain. So at this stage, I think I'm quite happy with it. I think I have all the essentials. I want to talk a little bit about data flow. So basically, a user, one thing I think I forgot is that if I go here, debt basically and savings categories should support an accumulated, savings should support accumulated amounts, which is basically the money you have saved in that fund. And that fund would be a category. All right. Debt should support leftover amounts. So what you have left on a loan to pay, basically. Both are some sort of accumulated amount that's either left to be paid or what you've already saved. But currently, these are categories, and in categories we don't have any field for to save that amount. So I need to add another field here. It should be for accumulated amounts. That's quite wonk. I think I'll just call it accumulated, and it will be a number type. I could call it amount, but amount is getting overused, and that will be a little bit complicated. I could call it ACC, amount also. I usually avoid such shortenings of words. In this case, that might be fine actually, because it's easily understandable as an amount, accumulated amount, basically. So I will use the same field for both debt and savings because it's the concept of it is very similar. You don't need a different field to store the number. The operations you do on it are different, which are determined by the type, the category. So in one case, you would have positive transactions with a plus sign. In the other case, it will be negative transactions, but the field is the same. And the accumulated amount is fine. So I wanted, before I thought I had forgotten that, I wanted to talk about how the user would interact with these entities and how the data will flow, basically. So, sorry. Basically, a user has his entity, his row in the database. When he creates an account, he gets a certain amount of default categories created. Each category is a row in the database, if you can imagine that. It has different types, these types. So, of course, when he creates an account, he might also get a budget for the current month created for each category. So you get a budget for each category ID. And initially, that budget will have a planned amount of 0, of course. Now, as the user goes in, he can modify these categories, delete some, add some. Depending on that, budgets will also change. And he can specify the budgets, more specifically their amounts for this specific month, what he has planned. This is this field, the planned field for the month. This is the same field for income, expense, savings, and debt. You have a planned amount for each of these. The difference is the operation you execute, not the actual amount. After that, of course, the user would execute transactions. And these, depending on the type of the category, will be either to receive income, to execute an expense, so money going out, to save money, or to pay off debt. Each one of these operations is a transaction row in the database, which has an amount, date, and it's related to a specific budget. The application, when it renders the user the view where he views all his transactions in some sort of table form, or his categories where he sees plans spent for the month, or any charts, would have to retrieve budgets basically for the month and the related transactions to them in order to calculate the total amount per budget that is already spent and compare it to the planned items. I don't expect this to be very intensive in terms of, yes, we have multiple entities in the database that are related, but the reality is that they are very few rows in scope this way because you have limited amount of budgets per month. These only depend on the number of categories, which are not expected to be an obscenely large amount. They will definitely be less than 50, even with the most powerful users on the application. And the transactions might be a bit more, but they're of course directly related to the budget, and they're small. They have a small amount of data. They just have an amount and a date. And in most cases, you don't even need to retrieve the date. So I don't expect to have a performance related issues because of these relationships. That is important to consider because at this stage you basically also determine the performance of your end user application. If you create a bad database design, you might be limited as to how quickly your app will work. In addition, if you don't normalize your database, meaning databases have a couple of normal forms. If you don't have, you can essentially put everything in one table. Like that's what a very novice programmer might do. If every user can have a sub object of, I guess, categories, no, budgets, which have transactions within them, and you can retrieve everything from one table. That would be very bad because you have a lot of repetitive data. Your database will grow in size exponentially more than with a design where you have different entities. And with that, your performance will suffer because for every request you will make to the server for data, you will retrieve larger amounts of data. And that slows down everything, including all software operations, calculations, transformations of that data, and the end user will have a slower application. So you need a good design here. That's extremely important. And I mean, I've done whatever I can to optimize this as much as possible. Hopefully, it will work out. It might not. We'll test it. I might change this design as we implement it. We'll see. But this is what I plan to start off with. I definitely might need to add additional fields. I might need to change it drastically. We'll see. That's what we're starting with. And I already have it saved as an XML file. The good thing about Dry.io is you can always open it and edit it in real time. All right, now that I have my ER diagram, I want to make another diagram real quick for the broad architecture of the system. I'll call it architecture diagram. You could do a UML diagram. There was a UML diagram for that. I don't remember the exact name. I think it was a component diagram or whatever. That's not that important. I'm doing this for myself and I just want to see how the actual services will work together, what kind of services are used. So we start with a database. This is a widely recognized symbol for a database. We need a database, of course. At least I plan to use MongoDB. I usually use relational databases, MariaDB, Postgres. This time I decided to go with Mongo for many reasons. The most important reason, the most decisive reason I think is to experiment a little bit. Just to briefly mention that you usually wouldn't find a better database. They each have drawbacks. They're fast at some operations, good at others. They have some advantages and disadvantages when it comes to declaring entities, searching data, migrating. So Database choice is not a simple thing. If you already are proficient with SQL, for example, going with an SQL relational database is that's a good reason to go with such a database. Knowing SQL will make your job a lot easier if you need to manipulate the data, etc. No SQL databases have become very popular. They do have some performance advantages and some disadvantages in some cases. I haven't used Mongo that extensively. I've built only very simple projects, throwaway projects for education. So I want to test it out. That's one of the reasons. It's definitely good for production. It's definitely not a lot of software applications that are serious are using Mongo, and it's all right. I'm sure it will be all right. We'll see how it works out. I also plan to use an ORM, object relational mapping, most likely Mongoose, I think. That's also a decision which you might not make. We'll talk about that later when we write the code. Right now, I want to specify the general software architecture. So we have our database. Of course, this will be a client-server application. There's no way around that. Even if you go serverless, there will be a server running. You just won't write the code for it. So the I'll just make a simple diagram with rectangles and stuff. No need to go to overly complicate things. We will have a server. This will be an HTTP server. That I was considering going with GraphQL, but I think I won't at the end of the day because the data I am using is very structured and I don't expect my RESTful endpoints to grow that much. I don't necessarily need the flexibility of GraphQL and I don't want to deal with the overhead of it in that case. So here in terms of technologies, I guess let me see the font size I was using here, 17, 18. I will actually unify these to both 18 so that I have similar font sizes at least. So for the backend, for the web server, basically, I'm planning to use a RESTful API and the technologies that will be the basically the spec of the server, the protocol will be HTTP, and I plan to use Fastify, Mongoose as an ORM, and that's pretty much all the dependencies and external software features, external dependencies I'll use. I don't, I might need a few other things, but I don't expect I'll need that much. The ORM will allow me to specify the models easily, and I'll use Fastify for routing, HTTP methods, and so on. That should be sufficient. All right. So basically, that will communicate. The arrow should be the other way around, probably. Although that's pretty ambiguous. The communication happens both ways. Let me see if I can specify two arrows here. I could from somewhere if I can find it now. So line end, line start. Yeah, here it is. Okay. And um so we have a RESTful API as the interface. This is an HTTP server in nature and it uses Fastify and Mongoose. And the client presentational layer, the client itself, will be, of course, a web application, at least. I am still considering if I want to build a React Native mobile app as well. That I think would be interesting to do and deploy. Overall, an interesting project. So we might do that, but for the MVP, for the first version, for sure, there will only be a web application because that's the most straightforward thing to do. And it will work on mobile and desktop as well. So, of course, in terms of technologies, I could go with just with React, or I was considering doing a client side app with React, but I do want server side rendering, to be honest. because it's just convenient for the user, better experience to have everything rendered on the server before you access it. Although this is a very dynamic app and static site generation is out of the question. And as I want server side rendering, I wouldn't want to work with just React. So I will go with Next here. I was really considering if I want to do Next.js just for variety in my videos because I do a lot of projects with Next. But I think overall it's a great choice in this case. And in many cases, because if you want server-side rendering with React, Next really makes it very easy. And the application will be very performant. So that's basically the architecture I have here. So I won't add any minor dependencies here because I also don't expect to have many. I will not use any user interface frameworks. I will write most of the components myself. I think I'll attempt to write all the components myself. I don't think I need a lot of dependencies because the application is very simple and I want to keep it simple and performant and flexible and extensible in the future. So we'll attempt to be as dependency free as possible. These essentials like the database and the object relational mapper and Fastify the router are important, including Next, because they will save me a lot of time and they will ultimately result in a better application because they have offer a lot of performance improvements and security features. But I wouldn't include something like a large user interface library like Material UI or something like that, the front end, or some pre-built libraries in the HTTP server because at that point the dependencies get too much and they impact performance negatively in some cases. So I'll stick to just a few dependencies that are well recognized to be stable and maintained. And I have trust and I have tested previously. So this is basically my architecture, the overview of the main software components. Quite simple. In some cases, previously I've done many of these side projects and applications. I have done a lot of applications with microservices. In this case, that's completely unnecessary, in my opinion. The HTTP server could be split up to multiple microservices if you have a more complex application. In this case, the entities are so few. Like here I have on the diagram open. We have basically 4 entities. Splitting this to microservices would be basically unnecessary. There's no logical way and no reason behind it. But that's definitely something to consider if you're building a more complex application that has more entities, more functionalities, more importantly, a logical way to split the services. But yeah, I've done that in the past. It's generally makes up for simpler microservices. Services in general, the HTTP server projects you have will be very simple. They'll have single purpose, which makes them easy to maintain, really. And when you open the code base, they become very easy to maintain, understand immediately, and scan their entire code base. The downside is orchestration, deployment, inter-process communication between the services is hard. In this case, it would be counterproductive to, for example, the authentication service with the like, I don't know, financial service or whatever. That would be counterproductive. So a monolith server in this case, I think is the better choice for the scope of this application specifically. I firmly believe there's no best architecture. It always depends on the app. And in this case, I think this is optimal, at least for starters. We'll see. None of this is set in stone. These diagrams, they are a way to start. Just my uh, plan. We'll see how it goes. We might swap all of these in the end. This might look completely different. We'll see, but I doubt it. I think it's a good architecture to start. With this, I'll wrap today's video. In the next one, we'll probably do the user interface design of the application. I like to do that before writing the HTTP server or the client because in most cases, how the user interacts with the application has a lot of impact on the functions the server has to support. And of course, it's extremely important for the client because the client will actually implement that user interface. So, if you enjoy the content, if you want to follow the series, don't forget to subscribe to get notified when the next video in the series is released. Take care.